On behalf of 24houranswers.com, I welcome you to today's lesson. In this video, we're going to look at another example of L'Hopital's rule, but our form is no longer going to be 0 over 0. It's going to be infinity over infinity. The same rule still applies, though, that we covered in example 2 and example 1, except our form is different. We have infinity over infinity. So we have this function g of x here, and we want to find the limit as x gets really big. As x approaches infinity, what is this function doing? Well, you may remember shortcuts from earlier on in Calculus 1 where really the degree of the top and the degree of the bottom, they match up, and we can use these coefficients, and that is going to be our limit for this. But let me extend that to L'Hopital's rule and show you how we'll still get 5/2. And then we'll also come over in Desmos and see how our limit is going to be 5/2 as well when we look at a graph. So if you let x get really big and you plug in a really big number and you square it and then you multiply it by 5, that's going to be a really big number, right? So here, that's going to be really big, and subtracting 1, that's not going to change much. The point here is this. When you let x get really big, this thing's going to get bigger and bigger and bigger. Therefore, right now, we're looking at infinity for our numerator. This thing will get bigger without bound as x gets bigger and bigger. Same thing for the bottom. 2 times a really big number squared minus 4 is still going to be a really big number, and there is our infinity over infinity form. So L'Hopital's rule, we can differentiate the numerator and denominator, and then we can try it again. So therefore, the limit as x gets bigger, x approaches infinity, of, let's take the derivative, we have 10x plus 2 up top. All I did there was take the derivative of the numerator over the derivative of the denominator is going to be 4x, and then that becomes a 0. So I'm just going to write 4x. We still have the same predicament here. We're still going to get infinity over infinity because x is getting big. 10 times a really big number is going to be a really big number, plus 2. Yeah, it's going to get bigger without bound. Same thing for the bottom. As x gets really big, 4 times that really big number gets really big. We have that same form going on, so we can repeat the process if necessary. So let's try this one more time. The limit as x approaches infinity, let's take the derivative of our numerator, which is going to be 10. The derivative of our denominator is going to be 4. And now we have the limit of a constant. I don't care what x is approaching now. The limit of a constant is going to be the constant. So we have 10/4. And if we simplify that, we get 5/2. So notice we really are getting those leading coefficients here since our degrees matched up. Now if we were to convert this to a decimal, we would have 2.5. So now let's go over in Desmos and have a look at this. Remember, our limit was as x gets really big. So as x gets really big, we're moving to the right. X is getting bigger here. Well, notice this y value. So x is getting really big, and right now our y value is around 2.6 if we round it. But if we keep on going, this 2.6-ish is actually getting close to 2.5. To show you that, I'm going to slide way on over here to somewhere around 100. So now x is big, and let's look at the y values now. 2.51. Notice that y value is getting closer and closer and closer to 2.5. As a matter of fact, if I just keep on going one more time, I'm going to come to 200, and now notice 2.505. That y value is going to get closer and closer and closer to 2.5, which is the same thing as that 5/2, and that is exactly what we've covered right here. And there you have it, another form, infinity over infinity. When you're trying to find limits, we can apply L'Hopital's rule, and in this case here, we take the derivative of the top and the derivative of the bottom, just as we did with the 0 over 0 form. And that's it for this video. I hope it helped. Be sure to check out our YouTube channel for more videos. Links to our social media are in the description below.